Are live. What's up, guys? This is Dem Keys, and today we are going to be carrying on learning about. Wait, what do I have? What do I have open here? Give me a second. Oh yeah, okay. We're gonna carry on learning about. Um, we're gonna carry on with the Hugging Face Small Course, and today we are specifically focusing on supervised fine tuning. Yesterday we finished looking into chat templates. Unfortunately, I didn't get too much time to look further into it, but I do want to mess around with it more because it seems like all of these are like different parts. I mentioned this yesterday as well. All of these things that we are learning, they're different parts of a bigger machine, and I feel like I need to learn how to build that machine to be able to properly appreciate what is going on here, and to be able to, I guess, do it better. So I do want to eventually get into learning how to build these large language models as well, or just language models in general. But before that, I feel like I need to familiarize myself with a bunch of, the more basic architectures. And this is, again, I've mentioned this before as well. I want to I want to familiarize myself. Well, I've already familiarized myself with feed forward neural networks, but I also want to get better at convolutional neural networks, recurrent neural networks, and then the transformer architecture. And there's a bunch of other different architectures surrounding that include a bunch of these previously mentioned architectures, like um, feed forward networks and convolutional networks together. They can sorry together they do actually get used together. um, I have to see in what situations recurrent neural networks get used, because I'm pretty sure there's a lot of use cases for that as well. And then, of course, the transformer architecture, because within the transformer architecture itself, there's a bunch of other smaller parts that make up that entire architecture, and I need to learn about those smaller parts as well. So I want to learn all of these things before I go into trying to build a language model, because I'm pretty sure building a language model is it's gonna involve a bunch of these parts and then some. But yeah, for today's stream, we're gonna be focusing on supervised fine tuning. Uh, where was I? I think here. I'm not sure. I think this is the, yeah, this is for page one, or I think module one, I guess. Hold on. Oh, this is for small LM. Give me a second. I need to close a bunch of tabs here because things are slowing down. So this is the course, and then this is parameter efficient fine tuning, which is module 3. I'm not done with 2 yet. I'm not even done with 1 yet, so we can look into that later. I was actually looking at that before I started the stream. Okay, so this is the data sets. We're going to be using the data sets as well. Um, okay. Wait, what is this? Instruction tuning. Oh, instruction tuning was the instruction tuning is the module's name, and that involves these two chapters. So here we got done with chat templates. Oh, I just remembered I didn't do the exercise for chat templates. Yeah, I didn't do the exercise for chat templates. I just remembered that yesterday before we ended the stream, we were looking into this notebook. Okay, all right. So here the exercise was to convert the data set into a template, wasn't it? Exploring chat templates with so-and-so. Okay. All right. Wait, should we carry on with that? Because, like, I mean, I already intended on jumping to supervised fine tuning. Nah, you know what? I can do the exercise off stream. Um, we can read during the stream. So we're gonna stick with the supervised fine tuning thing that we were planning on doing. Okay, so supervised fine tuning, or SFT for short. SFT is a critical process for adapting pre-trained language models to specific tasks or domains. While pre-trained models have impressive general capabilities, they often need to be customized at customized to excel at particular use cases. SFT bridges this gap by further training the model on carefully curated data sets with human validated examples. Okay, understanding supervised fine tuning. At its core, supervised fine tuning is about teaching a pre trained model to perform specific tasks through examples of labeled tokens. The process involves showing the model more examples of the desired input output behavior, allowing it to learn the specific, wait, no, allowing it to learn the patterns specific to your use case. SFT is effective because it uses the foundational knowledge acquired during pre-training while adapting the model's behavior to match your specific needs. Let me read that again. SFT is effective because it uses foundational knowledge acquired during pre-training while adapting the model's behavior to match your specific needs. It uses foundational knowledge acquired during pre-training while adapting the model's behavior to match your. Okay, all right. Okay. When to use supervised fine-tuning? The decision to use SFT often comes down to the gap between your model's current capabilities and your specific requirements. SFT becomes particularly valuable when you need precise control over the model's outputs or when working in specialized domains. For example, if you're developing a customer service application, you might want your model to consistently follow company guidelines and handle technical queries in a standardized way. Similarly, in medical or legal applications, accuracy and adherence to domain specific terminology becomes crucial. In these cases, SFT can help align the model's responses with professional standards and domain expertise. The fine tuning process. The supervised fine tuning process involves training model weights on a task specific data set. First, you'll need to prepare or select a data set that represents your target task. First, you'll need to prepare or select a data set that represents your target task. I'm realizing now that, yeah, okay, so in the chat templates section, we would have learned how to convert. Actually, no, hold on. So I wanna go back to this real quick. Because we did read. Oh, yeah, hold on. Wait, before we carry on, I wanted to talk about. Uh, I was mentioning yesterday. I think I streamed yesterday. So in yesterday's stream, I was mentioning that I was trying to find ways to do. How do I say this? I wanna start using, or well, I wanna go back to using, because I did use Unity on Linux before, but then I kind of just went back to using Unity on Windows. And now I'm kind of like experimenting with doing it on Linux again. And I want to work on projects in Linux. So what I wanted to do is just to be able to stream it, I wanted to record whatever I'm doing on the Linux machine and then stream that over to my Windows machine, and from my Windows machine stream it to Twitch. And I was trying to find a way to accomplish the streaming from Linux to Windows. And one solution that I found was RTMP, which is I forgot the full form, but it's basically for streaming. It's a protocol for streaming audio and video and media and stuff like that, in real time. More specifically, like that's the whole idea behind it. It's for streaming in real time. So one solution that I got, and I've seen the solution mentioned before as well, I just never looked too deep into it. One solution was to use OBS to capture the audio stuff, the audio and video. In my case, it's going to be just video. But yeah, use OBS to capture the data, and then send it over to an Nginx server, which is configured to work as an RTMP server. And so then that server is going to be hosting that media. And so then my understanding is any machine across the network can then access that Nginx server using the RTMP protocol. So the way we type HTTPS or FTP or those kinds of words, we can type RTMP, and I'm assuming whatever the IP address is, or I think whatever. I'm not sure if you're able to specify some kind of like domain name or something. But yeah, I'm gonna have to see how it's meant to be configured. The point is you can access it using that kind of an address via RTMP directly, which means I can then pull that data. I might even be able to. Okay, I'm not sure if the browser is going to have the capability of playing those frames that are going to be streamed, but that's one option. I can try and access it through that. Another option that was given by Llama is to try using VLC media player to stream that. And another option that I found, which I was trying to find a way to read RTMP data and display the frames in Python, because like in if you're using Python, more specifically OpenCV, you then have access to certain UI tools that OpenCV allows, and OpenCV also allows you to do video capture using either your webcam or some other source. So you can probably even read from not probably, you can read from files and then display those frames. And yesterday I found out that, or maybe it was today, I found out that you can actually specify an RTMP address in there, and it's going to read those frames, and you can display those frames as well, which is great. That's actually amazing for me, because then what I could do is I could write an application that's gonna get those frames, and I can then set up a window that displays those two frames in different locations, and then on the Windows machine, or well, here on this machine that I'm streaming from, in OBS I can set up I don't know, window capture or some other kind of capture to capture different sections, and then on stream it's going to look like it's being done on this machine. So it's gonna look pretty much like what you're seeing right now. At least that's what I'm hoping is gonna happen. And through doing that, I'm gonna be able to stream. I'm gonna be able to do the development on the Linux machine while streaming it to Twitch, which I'm excited about. I'm excited to give that a try, because that's also going to allow me to, do a bunch of dev work, do a bunch of Unity related exploration that I've been meaning to do. There's a bunch of packages that I wanted to check out, but I mean, I would be checking them out in my free time anyways, like off stream anyways, but I kind of want to do them on stream. And this is going to allow me to do that. Now, I haven't tried this out yet, this is so far, it's all just theory, but because I've seen a bunch of people recommending this, I know it works to a certain extent. How well it's going to work for me, I'm not sure. I'm gonna have to try it out first. So I need to set up OBS on this machine, on this well, on not this machine, on one of my Linux machines that I want to stream from. And then I'm also gonna have to set up Nginx. I need to look into. I've actually been looking into it. I was looking into it shortly before the stream as well. I'm looking into RTMP. I'm trying to understand the protocol. I'm trying to understand the idea there, because what I'm getting here is that using the RTMP protocol, you can have an RTMP client and an RTMP server, and then the client is gonna send the data over to the server. So the client is gonna capture whatever, frames, or the client is either going to capture live frames or read frames or something like that. It's going to have frames, and it's going to send that data over to the server using the RTMP protocol, and then the server is going to host that data, and even the server is implementing the RTMP protocol, so any other client can then access that data, again using the RTMP protocol. But I need to get a better understanding of how things are meant to work, because currently the idea is on the Linux machine, OBS is going to be running. And oh, I also found out that on OBS, or in OBS, you're able to specify. So like you can select if you want to stream to Twitch or to YouTube. But I also found out that apparently you can also set a custom location, which is great. Or well, I mean, it might have been there and I just never noticed it. I don't know. But either way, it's great. Um, I that's what I'm supposed to be using. In that custom settings thing, I'm gonna have to specify the RTMP server so that OBS is gonna then stream the data directly to the server. Now, something else I want to try out in my free time is sort of generating data myself, or maybe, okay, maybe even reading data from a file, from like a media file, and then streaming that over to an RTMP server. I'm gonna have to find a library on well, I'm gonna have to find a Python library that can do that. I don't know yet if there is one that's widely used. I haven't looked too much into RTMP, but this is where I'm at right now. I'm doing research on RTMP and Nginx, and well, I mean, I don't need to do research on OBS, but I do need to do research on using RTMP in OBS. And hopefully, if everything goes well, we should be able to stream. I could actually make those mute streams. Yeah, those could be my mute streams where I'm just silently working on the game, whatever the game might be. I could probably come up with the idea for the game like on stream. Shit, dude, I could be streaming a lot more. Though, I mean, they're gonna be silent streams, so like I don't know to what extent I should try to stream like the entire. I'm not sure what I'm trying to say here, but like it's one of those things where like, do I want to be streaming like 12 hours or something, even if it's like, okay, sure, it's a silent stream, it's a mute stream. Do I want to be doing that? Kind of yes and kind of no. That's the best answer that I can give. Kind of yes and kind of no. Like I want to stream, but like I don't want to be streaming all the time. Though, okay, I mean, I'm saying this right now, right? I don't think that's going to be the case. I don't think I'm going to be like, streaming all the time, like the entire process, the entire development process. I would like to do that, but like it's just not always possible. Though, it being a mute stream makes it a lot more possible because then I can start up the stream whenever I want and just get to deving. Anyways, I needed to check something here. We need to install TRL, don't we? Setup chat format. Yeah. Actually, no, we don't need TRL right now. Um, do we need TRL? Well, yeah, okay. You know what? Let's install it. So we're gonna run this, let it install TRL, and then we need to run the next thing. What was I saying before I went off on this tangent? Dude, I'm excited. I'm excited to work on a new project in Unity, and I'm hoping that the Linux version of the Unity editor holds out well, even during even with more complex projects. Because so far, my experience with the Unity editor on Linux specifically it's been great. More specifically, with the built-in render pipeline. With scriptable render pipeline, it's been horrible because probably because of my hardware. But with the built-in render pipeline, it's been great. So I'm going to be using the built-in render pipeline. And where was I going with this? I was talking about the Unity editor on Linux and how I'm excited to be. Oh yeah. So what I've noticed so far is that, dude, this blew my mind. I had to like tweet about it. I even posted on threads about it because I wanted to get like other people's opinion on this. But like it blew my mind that when I try to open a Unity project on Windows, I just know it's going to be a minimum 15 minute wait. It's going to be anywhere between 15 to 30 minutes. And that's for opening a project that has already been created. For creating a new project, I've had to wait for a minimum of 45 minutes. Dude, it sounds insane to say that, but I've had to do that. That is crazy. That is insane, dude. I've had to wait for, okay, for the sake of, not making it sound like way too crazy, I can take it down to 30 minutes. Let's say I've had to wait for anywhere between 30 to 45 minutes just for the project to be created and the editor to open and be in a usable state where I can actually interact with the UI. Like I've had to wait for that long. And then, okay. So here's what I was tweeting about, and here's what was blowing my mind. That I have to wait for this long to open a project on Windows, open a Unity project on Windows, right? Minimum 15 to 30 minutes just for opening a new project. Or, well, just for opening a project that has already been created, right? And then I look at Godot, it starts up instantly. And this isn't me trying to advertise Godot. I'm just saying, like, Godot starts up instantly. You try to open a project, it opens up in like seconds. Maybe you might have to wait for minutes, right? I've never had to wait for 15 minutes for a Godot project to open up. To be fair, I haven't worked on complex projects in Godot, but I've never had to wait for that long for a project to open up on even on Windows. This is why it was blowing my mind that on Windows, opening up my Unity project it's a minimum of 15 to 30 minutes of waiting time, right? If I'm trying to open up a Godot project, it's a few seconds to a few minutes. And then then you take a look at Linux. On Linux, both Unity and Godot projects open up within seconds to minutes. So somehow on Linux, and these are older Linux machines that I'm talking about. These machines, their hardware is older than my Windows machine. Even then, they are able to open up the Unity projects within seconds or maybe minutes. Like, how does that work? That's just blowing my mind. That's crazy. And I'm pretty sure SRP being in the project, or the project being built on top of SRP, it has something to do with it, because SRP introduces a bunch of extra systems, and that kind of slows things down further. So I'm pretty sure that if I had a project that was running the built-in render pipeline, things would have been a little faster, but they would have probably been just about the same. They would have probably been like there would probably still be a couple minutes of wait time just to open up that project. And that's crazy to me, dude. Like I just don't have to wait on Linux when I'm doing this work, and that's really important. Like being able to open the project quickly and just get to work quick, that's really important. I can't stress how important that is, not just for me, but for a lot of other people. Because it makes it so your flow doesn't get interrupted. And it's the same thing with like compiling new scripts. So if you've changed a couple of lines of code in your scripts, or if you've changed a couple of lines in your code, well, I mean, even a couple of lines of code in your scripts, like that's fine as well. If you've changed a couple of lines and then you tab back into Unity, it's going to start recompiling the scripts, right? And then it does a bunch of like reloading and stuff. On Windows, I have to wait for minutes. I'm not even exaggerating. I have to wait for minutes before I'm able to use the Unity editor again. But then you look at Linux, I have to wait for a couple of seconds and it's good to go again. Like, dude, it's blowing my mind how quick everything was. It's, I'm legit being reminded of, like, as I'm doing stuff on Unity 6, the latest Unity version in 2024, as I'm doing work on Unity 6 in Linux, the speed is reminding me of how fast the previous Unity versions were on my system. When I say the previous Unity versions, I mean stuff like Unity, let's say Unity 5. I think Unity 5 is a pretty good example there. Yeah, I'm being reminded of how quick things were back in those days. Like that's crazy to me, dude. That is insane. I don't know. It's still blowing my mind. I just can't get over that. Even as I'm like I've already tweeted about this, I've posted on threads about it, and even now as I'm telling it on stream, it's still blowing my mind that it's just that slow on Windows, dude. I mean, at first I was blaming my hardware, and I was like, okay, to a certain extent it might be my hardware's fault as well. But then if it was my hardware's fault, then Godot would have been slow as well, right? It's not slow. In fact, it's very fast. It is super fast. It's the Unity editor that was slow on Windows, but then the Unity editor on Linux is fast again. Like, dude, I don't. Okay, I'm gonna stop talking about this. I'm excited to start working on stuff in well, I'm excited to start working on a new game project in Unity. I should probably dedicate a stream to just coming up with an idea for a game. Yeah, I should do that. Dude, you know what the thing is? I want to I want to try and base things around deep learning somehow. That's what I'm trying to do, cuz I'm trying to build a game, right? I'm trying to build something that would be fun to play, but I'm also trying to incorporate ML and deep learning into it, mostly because I want to, because that's going to help me practice ML and deep learning much, much more. I'm going to be I'm going to be practicing them a lot more if I'm actually working on a practical project with them. It's going to teach me so much more about working with Onyx and just using Centis in general. So I kind of want to base a lot of it around machine learning and deep learning. Okay, I'm going to take a short break from yapping because in the next 35 seconds, now 35 seconds, there's going to be an ad playing. So I'm going to hit the ad button right now and I'll see you guys in 30 seconds. Okay, welcome back. Um, yeah, I was talking about wanting to incorporate machine learning and deep learning into whatever game I'm making. I have to see how I want to go about doing that. It also doesn't necessarily have to be in 3D. It can just be a 2D game as well. In fact, 2D might simplify things much more. Though I mean that's not necessarily always true. It could maybe complicate things depending it depends on what I'm trying to do. It depends on yeah, it depends on what I'm trying to do. Okay, so I'm done running this thing. Let's clear let's clear the cell. Sorry, let's clear the cell output. I mean, and now let's run this thing and then we need to go down here. Oh yeah, oh shit. I could have just looked at this. I was planning on running this thing again. Okay, so what I wanted to look into was what the data looked like. Because I was curious if it looked like a template or not. If it had like those template like tags or stubs or whatever they're called. I wanted to see if they had that. They don't. They look like just plain text. Um, Hold on. Let's see. So messages. This is a bunch of messages. In train, there's a bunch of messages, and in test, there's a bunch of Oh, train and test is two. Yeah, okay. It just clicked for me because yesterday when we were looking at this, it didn't click that yes, these are two separate data sets. One is meant to be used for training, and the other is meant to be used for testing after training. So we just need to look at train. What are we missing here? Oh, we're not missing anything. This is just the output from what I'd done yesterday, where I learned that apparently you can raise an error, even outside the context of what do you call it? Even outside the context of like try-catch blocks, you can still raise an error. Okay, so this thing is being downloaded now. Um, right. So this is gonna take, well, it's not gonna take time. It's just gonna, you know what? This is like 3 of 9. So this will be done pretty quick. We can read. We can carry on reading in the meantime. Okay, the fine tuning process. The supervised fine tuning process involves training model weights on task specific data set, on a task specific data set. First, you'll need to prepare or select a dataset that represents your target task. This dataset should include diverse examples that cover the range of scenarios your model will encounter. The quality of this data is important. Each example should demonstrate the kind of output you want your model to produce. Next comes the actual fine-tuning phase, where you'll use frameworks like Hugging Face's transformers and TRL to train the model on your dataset. Throughout the process, continuous evaluation is essential. You'll want to monitor the model's performance on a validation set to ensure it's learning that wait, hold on a validation set to ensure it's learning the desired behaviors without losing its general capabilities. In Module 4, we'll cover how to evaluate your model. The role of SFT in preference alignment. SFT plays a fundamental role in aligning language models with human preferences. Techniques such as reinforcement learning from human feedback and direct preference optimization rely on SFT to perform a base level of task. And no, hold on. Techniques such as RLHF and DPO rely on to form to form a base level of task understanding before further aligning the model's responses with desired outcomes. I need to read this again. Techniques. Okay, so these are the techniques that rely on SFT to form a base level of task understanding. So the whole idea here is to make the model understand the task that it's meant to be performing, and after it understands the task, then we align the model's responses with the desired outcomes. Is that what's going on here? I hope I understood that correctly. I'm not sure. Real quick, let's check. This should be done by now, right? Yes, it's done. Awesome. So we're going to run this again. Actually, we should probably get the length because this is a dictionary, isn't it? No. So okay, this is a dictionary of wait, let's read. Hold on. So what are we looking at here? This is a dictionary, isn't it? This is a data set. All right. What are uh does this data set have hold on. I want to see if okay, does this data set have keys? It does not. Does this hint at something else? Dataset object has no attribute keys. Okay, so it seems like the dataset might have. How would I find this out? You know what? Okay, does this have this? Oh God, that is long. That is big. That's what she said, but that is big. Okay, yeah, we cannot. Yep, nope. I can't get anything useful out of that. How would there be a len function? Because like I'm trying to figure out how I would go about figuring out. Okay, so um, the data set has a dictionary, and the dictionary has features and number of rows. Okay, so the data set has fine. What if we try to read? Wait, if it's would I be able to access this as dictionary? So let's say features. Nope, that does not work. Column features column features is not in the data set. Current columns in the data set are so and so. Oh, okay. Wait. What does so okay. What I was trying to do was I was trying to do this, right? Just to get the length. And I wanted to see if there's a way to if there's a better way to find out whether something is a collection or a dictionary. But okay. So because we have a length here, that means we can index it, right? When we index it, we get this. So this, I'm assuming, is returning a dictionary. The dictionary has one key, which is messages. What other keys does it have? So it has messages and source. All right, so this is the first thing in messages, right? Um, messages. This is a dictionary. This is a dictionary, right? So we have messages. No, hold on. How am I accessing this? So I'm accessing the first row, right? The first row contains. So we have messages. Messages is a list of dictionaries where each dictionary contains. Well, messages is basically a row of messages where each message is a dictionary and like it contains the content and the role. And then we have sources. Okay, so let's read only messages. That's only messages. Okay. And this contains how many? It contains two examples. So there's user and assistant. Oh, so it's giving what the user is going to ask and what the preferred answer from the assistant is supposed to be. All right. So let's try this. Wait, back up. So if I would have scrolled down, I probably would have seen the source as well, right? It's just that this text was long, so even the answer was long, and so it kind of looked. Okay, so source is small rewrite. I'm not sure what source is supposed to be here. Oh, source is one of the like categories they have, right? Like one of them was everyday conversation or everyday conversational, something like that. All right. Okay. So, yeah, cool. Let's carry on reading this. Where was I here? May not always generate outputs that match human preferences. Okay. SFT bridges this gap by introducing domain specific data and guidance, which improves the model's ability to generate responses that align more closely with human expectations. Supervised fine tuning with transformer reinforcement learning. A key software package in software, no, in supervised fine tuning is transformer reinforcement learning or TRL. TRL is a toolkit used to train transformer language models using reinforcement learning. Built on top of Hugging Face Transformers library, TRL allows users to directly load pre-trained language models and supports most decoder and encoder decoder architectures. The library facilitates major major processes of RL used in language modeling, including supervised fine tuning, reward modeling, proximal policy optimization, and direct preference optimization. We will use TRL in a number of modules throughout this repo. Okay. Supervised fine tuning tutorial. And then there's a chat template. What am I looking at here? So I've opened this thing up, right? And then there's a chat templates tutorial, which I thought we finished yesterday. Let's still open it up and see what it's. Oh, it's the notebook. Wait, isn't the notebook the exercise, or is it? So this says example. Is that what we were looking at here? Yeah, yeah, this was the same thing. Yep, this was the exact same thing. And then this is missing. Okay. Give me a second. Let me just look through this. Maybe I need to refresh the page just so the link leads to somewhere. Though I don't think. Wait, I'm not sure. Hold on. I think I did refresh it like after the last time it was updated. So I don't think that's gonna be the issue. Let's try it again. Anyways. This is chat templates. Okay, so we got done reading this yesterday. All right. Supervised fine tuning tutorial, and it is missing. Okay, let's take a look at the notebooks folder and see if there's something else there. They have SFT fine tuning example. All right. Oh, you know what? Maybe I should report an issue that the link is broken. Yeah, I should probably do that. Let me write this down. I mean, someone must have already done that, but let me write it down anyways, so I can report it later. Um, create issue for broken notebook link for SFT, or broken notebook link. Yeah, for SFT on SFT page. This is just horrible. Uh, Let me just type it in plain English. Um, on on the page explaining SFT, the link at the bottom that should lead to the SFT example notebook seems to be broken. Report that. Okay. Where were we? No, don't sign in. Oh, holy shit, dude. I was trying to get rid of that stupid UI thing. I tried clicking elsewhere, it wouldn't go. Okay, anyways. Okay, cool. So, we are probably going to be using TRL. Yeah, we're going to be using TRL. Sorry, zoned out for a bit. Okay, so we're just gonna take a look at this because I don't wanna get into this before doing the other, like before doing the chat templates thing practically. Okay, good. So this is going through that same thing again. TRL will format input messages based on the model's chat templates. They need to be represented as a list of dictionaries with the keys role and content. Okay. Configuring the SFT trainer. The SFT trainer is configured with various parameters that control the training process. These include the number of training steps, batch size, learning rate, and evaluation strategy. Adjust these parameters based on your specific requirements and computational resources. Okay, cool. So we do that and then train the model and then save the model. I don't think I've tried saving a model after fine tuning it. To be fair, I don't think we ever went too deep into the fine tuning portion of the Transformers library, because after finishing the quick tour, I think we were supposed to. Oh yeah, I was looking into inference, and fine tuning was gonna come up later on. It was one of the next chapters, either the next chapter or the chapter after that. It was fine tuning. Um, well, I guess we're gonna be learning fine tuning through this now. But before this, I think I need to go back and learn how to train the mod. You know what? Wait, this is under Transformers? All right, so let's take a look at, give it a second, it's being a bit slow. So we have quick tour here, and this is where I was. So run inference with pipelines. There was a lot of interesting stuff in this. Then write portable code with autoclass, pre-process data, and then fine-tune a pre-trained model. So these were the four chapters that were quite important, or at least I felt like they were important enough for me to spend time going through them just to get a better understanding of doing stuff. But I kind of have to divide my time amongst a bunch of things now. So we've got this, right? So basically we have to carry on learning about the Transformers library and how to do stuff with the Transformers library. We also have to do we also have to learn basic neural network architectures, like, feed forward neural network, which we've already done, convolutional neural networks, which I haven't yet done, and also recurrent neural networks, which again, haven't yet done. And then I have to go to more complex architectures like transformers or the transformer architecture. And then there were some other architectures that were based that were built using the more basic architectures as well. So like the basic architectures were used as building blocks to build those more complex architectures. I also need to explore the concept of backbones, because that's another thing that seems to be used a bunch, where apparently changing the backbone of the neural network can affect its behavior. It's one way of customizing the neural network without having to completely rebuild the entire neural network. That's another thing I need to explore as well. And I think both PyTorch and Transformers gives you the give you the ability to do that. Right. Okay. But for the time being, we are doing this, so we're gonna stick with this. I don't want to take time away from, because otherwise I'm just never gonna do anything. I'm never gonna finish any of the stuff that I was trying to do. I kind of have to divide my time amongst all of these things. I mean, in the end, it's all gonna kind of like come together. I'm pretty sure about that. Like a lot of these things are connected together, and in the end, all of the knowledge that I'm gaining, it's all gonna kind of come together and benefit me in various ways. So I'm gonna be using all of that knowledge in the future. So it is worth putting the time and effort into it. But even if I won't be using that knowledge, I'm certain topics I just want to learn them for the sake of satisfying my own curiosity about how those things work. Um, and I mean, they might be useful in the future, but like a lot of this stuff, I personally feel like these are like the basic building blocks. These are like foundational. This is foundational information that I need to learn before I move on to doing more complex things, because otherwise I'm gonna have trouble understanding the more complex things. That's kind of why I want to put time into this. But like, I kind of have to divide my time amongst things. So we have like the basic neural network architectures, right? Then we also have transformers, the transformers library. I need to learn about that. I need to continue learning about that. Then we have this course, the small course. Then we have the 5 day Gen AI course. I want to get through that as well before it becomes old, because that's also gonna teach me a bunch about these models, and that's gonna make me use Google AI Studio more, which I definitely want to do. Give me a second. Let me hydrate. Okay, so where do we go from here? There might be. Okay, we can probably go through. Hold on. Wasn't there a supervised fine tuning thing here? Okay, supervised fine tuning trainer. So in the TRL documentation, this is under TRL. Okay. All right. Let's take it. Let's take it from the top. So we'll open up TRL. Oh yeah, under TRL there was a either a quick start or a quick tour section. Why is this page stuck? Okay, yeah. So we looked at this yesterday, and then from here we were led to the next page, a brief overview of what each public model class does. Let's take a look at some of these classes. Here we had SFT trainer. Okay, training with so and so. This is actually, I found out that this what was this, parameter efficient fine tuning, I think. This is a separate. This is another library. There is a separate library by Hugging Face called PEFT, and I believe Laura is a part of this. Uh, Again, I think it's performance efficient. No, parameter efficient fine tuning. Laura is apparently covered in this. I was looking into it before I started the stream. Let me show you guys. I think I also need to close a bunch of these tabs, dude. It's kind of slowing things down. Okay, let's close a bunch of these and only open them when I need them. Here. So in module 3, it covers PEFT. And here they cover LoRa and something else as well. Learn LoRa, prompt tuning, and efficient adaptation methods. Okay, what else is there? There's evaluation. There's vision language models. I'm interested in that because I've been seeing vision language popping up. I've been seeing like this term being mentioned quite a bit. A bunch of newer models that are being released. They're being categorized as vision language models. Then synthetic data sets. Create and validate synthetic data sets for training. Okay, and then inference. Infer with models efficiently. All right. Okay. Oh God, why is everything so slow right now, dude? Okay. Models. Let's see what is under this. With with the auto model for causal LM with value head. My God, this is a name, dude. Class TRL supports all decoder model architectures in transformers such as GPT-2, OPT, and GPT Neo. In addition, with my God, with auto model for sec to sec LM with value head, you can use encoder decoder architectures such as T5. TRL also see, dude, a lot of this stuff relies on the transformer architecture. A lot of these models are built using some kind of transformer architecture. So I need to learn about the transformer architecture itself. I feel like that's really, really important. I mean, I was planning on doing that anyways, but I feel like now it becomes even more important to learn about the transformer architecture before going any further with like more advanced topics. Okay, TRL also requires reference models, which are frozen copies of the model that is trained. With create reference model, you can easily create a frozen copy and also share layers between the two models to save memory. Sorry, zoned out. Um, okay, auto model for causal LM with value head. Okay, what else? For sec to sec. Okay, so that's two of them. Oh, so those are the two main ones, and then there's pre-trained model wrapper. Not sure what that does. A wrapper class uh around a so and so to be compatible with the so and so class in order to keep some attributes and models of the pre-trained model class. Okay. All right. So I'm trying to think where I want to go from here because we can finish exploring this real quick, right? So we had the setup chat format thing. We downloaded the data. Sorry, zoned out. Okay, so um, we call setup chat for which setup chat format was for the tokenizer and the model, not for the data set. For some reason, I was connecting it to the data set. Okay, so then I can probably just pick. Yeah, I can probably just pick any message and pass it into the tokenizer. Yeah, that would work, right? Well, it depends on what this model has been trained on. Though that would be interesting. Hold on. So we have, let's say, let's go for this. Okay, Mark made a chalkboard that is 3 feet wide. It is X time. This is all math related stuff. Okay, let's go higher. This is again math. What if I went for everyday conversations? Oh, is the index too big? Yeah, the index is too big. Okay, so let's do 500. Full topic, communication slash digital. Oh, this is cool. So they give you the topic as well. All right. Hi, hello. How can I help you today? So and so. Okay, okay, dude. So we could pass this entire thing into the language model, and it would just continue the conversation from there. Let's take a look at some other ones. Let's try 550. Water cycle slash precipitation. So water cycle or sweating? Oh no, precipitation isn't necessarily just sweating. Okay, my bad. I always thought it was mainly sweating, as in, human sweating. Okay, so I guess precipitation is kind of just water kind of leaking out of something, or oozing out of something. Precipitation is when water falls from the sky to the ground, like rain, snow, or hail. All right. Okay. So the conversation goes like so. Hi there. Hello, how can I help you today? Then dude, I want to learn how the model makes sense out of these dictionaries that we are handing over to it. Like how do these dictionaries, how does this list of dictionaries get converted into data that's going to give the model context of the conversation, and then also allow it to continue the conversation? You know what we could do? We could try asking Llama. Sorry, zoned out. Um, all right. What was I gonna ask? Um, give me a second. Okay, so I was gonna ask Lama something. Yes, I was gonna ask about how the. All right, so I'm learning about LLMs using uh, transformers. Oh, you know what? Let's. Okay, I'm learning about LLMs and chat templates using transformers. I'm wondering. Oh, wait. I just remembered. Yeah, I think I already know the answer to my question because I just remembered that this text doesn't get fed into the model. Somehow I forgot. Somehow it just didn't occur to me that yes, I know this. Um, sorry, zoned out. Okay. Um, somehow I didn't remember that I knew this, but okay. So we have the chat messages, right? The chat messages, or well, just the messages, they get converted to the template version, and then that template version gets converted to tokens. So that template version of the messages gets tokenized, and those tokens get fed into the model. Okay, right. So now then I have a different question. So from what I understand, so okay, here's what I'm gonna do. I'm gonna because these models are meant to kind of predict the next text and just kind of carry on the conversation. I'm just gonna mention what I know, and the model is just gonna give me more information based on that. So from what I understand, um, in order to feed input to an LM, we create a list of messages, each message being a dictionary containing a role and a content. Um, and then this, okay, yeah. And then this, oh, wait, yeah. And then we apply a chat template to this list of messages so that we get um, a template string. And then this is a long ass sentence. Okay. And then we tokenize that string and feed the tokens into the model to get the output from it. Is that right? Okay, so the model understood what I was talking about, what I'm trying to explain here. Yes, your understanding of how to use chat templates with large language models using Transformers library is largely correct. Here's a breakdown of the process. Creating a list of messages, okay, fine. Applying the chat template. Next, you apply the chat template to the list of messages. The chat template is typically stored in the tokenizer and specifies how to format the conversation into a single tokenizable sequence. Okay. Oh, wait. Yes, this is an important thing for me to remember, that the idea behind chat templates, even though I kind of already knew it, but seeing it written in this way is going to help me remember that, yeah, this is a thing. Like this is what it's supposed to do. The whole idea behind the chat template is that it specifies how to format the conversation into a single tokenizable sequence. So the entire conversation gets kind of consolidated into one string, but because of the format, because of the chat template, we are able to distinguish, or the model is able to then distinguish between the different messages. You use the apply chat template method of the tokenizer to achieve this. Okay. All right. This will convert the list of messages into a formatted string according to the template specified for the model. Tokenization. After applying the chat template, you need to tokenize the formatted string. This step is usually handled by the tokenizer itself. All right. And then feeding the input to the model. Finally, you have the tokenized input. No, what? Finally, you feed the tokenized input into the model to get the output. Here's a more complete example. All right, that's fine. Great. Cool. So, what I'm trying to understand is how the model is able to recognize that these tokens represent a conversation containing multiple messages and multiple roles, and multiple content. All right. Um, so to understand how a large language model recognizes, give me a second. Okay, to understand how a large language model recognizes and processes tokens that represent a conversation with multiple messages, roles, and content, you need to consider several key aspects. Chat templates and formatting. When preparing input for an LLM, you use a chat template to format the conversation into a single string. The template typically includes markers or special tokens that distinguish between different roles. Example, user and assistant, and their respective content. For example, the apply chat template method in the Transformers library formats the conversation in a way that the model can understand in a way that the model can understand the different roles and messages. Token type embedding. The use of token type embeddings is crucial in distinguishing between user what? User utterances. Okay. Between user utterances and bot responses. Utterances. I've heard the word utter being used before, as in, don't utter a word. I've never heard the word utterance. That's interesting. Okay. Between user utterances and bot responses within the conversation. As described in the token trails approach, each wait, as described in the token trails approach. You know what? Okay. We'll finish reading this and then ask the question. I might have a different question by the end of this, but okay. As described in the token trails approach, each token in the conversation is associated with a token type embedding that indicates whether it belongs to a user or a bot. Oh, okay. This embedding is combined with the word embedding to create a final embedding that the model uses to understand the context and roles within the conversation. Tokenization process. During tokenization, the formatted string is broken down into tokens, which are sequences of integers representing various elements of language. The tokenizer assigns unique numerical identifiers to each token, allowing the model to process and interpret the numerical data. This process ensures that the model can recognize the structure and context of the conversation, including the different roles and messages. Contextual understanding. LLMs are trained on vast amounts of text data, which includes various conversations and dialogues. This training enables the model to recognize patterns and understand the contextual nuances of conversations. When the model processes the tokenized input, it uses the training, it uses this training to generate responses that are coherent and contextually relevant, taking into account the roles and content of the previous messages in the conversation. Okay. Okay, so a random thought just occurred to me, and this is a question that I've had, for a while, but like it just came up again. Um, so I'm wondering about the so okay, LLMs are not that great at holding their memory of a conversation for too long. More specifically, the context of the conversation. They kind of lose the context of the conversation after a while, and I'm wondering if that has something to do with the amount of messages that you're willing to feed into the model. Because the larger the list of messages, like okay, if you're trying to feed the entire previous chat history and you've been chatting with the model for a while, it's going to be a pretty long list of messages, right? If it's a long list of messages, that means that the the templated string is going to be long, and if that is long, then that means that the tokenized input is also going to be long, which means you're going to be feeding a large amount of data into the model. I wonder if it's a limitation where the model is just not able to accept that big of an input, or or if it's the fact that the model would be slower if it was a big amount of data being sent in. I think I'm only going to understand this once I understand how these models work, because I know with like okay, with these models you're able to specify the number of tokens. You can specify like max new tokens. Oh wait, no, that's max new tokens, not old tokens. Yeah, I'm okay. Yeah, I'm not sure. I'm not sure if that has anything to do with the input. But yeah, that was just a random thought that occurred to me just now. Like, because I wanted to try and tackle the memory problem with LLMs at some point in the future. Once I actually, learn how to build LLMs or just LMs in general, then I did want to tackle that. And there are a couple of people who have already done a bunch of research on this. There are already papers on this to help tackle the memory problem. I think one of them was using a recurrent neural network. I remember reading one of the papers. But yeah, in the future, I do want to look into that. Give me a second. Okay. All right. Um okay, memory management. In managing conversations, especially those that span multiple turns, the model must retain. Oh, dude. Okay, I think it's yeah, I think this is going to talk about that. The model must retain context. Techniques like the conversation token buffer memory in LangChain ensure that the model retains a specified number of tokens from the conversation, allowing it to stay contextually aware without exceeding the token limit. This approach helps in maintaining the flow of dialogue and ensuring that the model generates responses that are relevant to the ongoing conversation. Okay. I've been wondering for a while now, why is it that LLMs are not able to maintain context of the conversation for too long? After a certain period of time, it seems like they have forgotten what the original context of the conversation was. So, okay, before this thing answer, I don't want to call it thing, but before Llama answers, you know what? Okay, it's probably going to take some time. So, my now, okay, I understand that the model is just predicting the next tokens. It's predicting the next tokens based on a few of the previous tokens that have been provided to it. I understand that, but like, I still want to try and get an understanding of like, if there's some kind of limitation aside from just token limit, if there's some other reason why the LLM eventually forgets what we were talking about. Oh wow, there's a bunch of okay. The inability of LLMs to maintain context over an extended period or conversation length is due to several key limitations. Hold on. All right. Is due to several key limitations and characteristics of these models. Context length limitations. LLMs have a predefined maximum context length, which is the number of tokens, words, characters, or subwords that they can process in a single input. This limit is determined by the model's architecture, training data, and computational resources. For example, models like GPT 3.5 or Llama 2 have context lengths of up to 1496 tokens, while others like Llama 3 can handle up to 8192 tokens. Stateless nature. LLMs are stateless, meaning they do not retain context or memory of previous inputs once the context length limit is exceeded. The model's ability to recall information is confined to the current context window, and it cannot access information outside of this window. This results in the model not being able to, oh shit, I missed the add timer. Okay, so an ad will be starting in some time. Okay, this results in the model not being able to remember earlier parts of the conversation once the context length limit is reached. Primary and recency bias. Research has shown that LLMs tend to perform better at processing information at the beginning and end of the context window, a phenomenon known as primary bias or recency bias, respectively, and recency bias, respectively. Oh, so at the beginning is primary bias and at the end is recency bias because at the end is going to be the most recent messages. I hope I got that right. Okay. This leads to a missing middle issue where the model struggles to accurately recall information in the middle of the context window. This bias further exacerbates the difficulty in maintaining long-term context. Computational and oh, okay, there's an ad playing right now, so I'm going to take a hydration break and then we'll continue. Okay, where was I? This leads to a missing middle issue where the model struggles to accurately recall information in the middle of the context window. This bias further exacerbates the difficulty in maintaining long-term context. Computational and memory constraints. Increasing the increasing the context length significantly increases the computational and memory requirements. The self-attention mechanism in transformers, which is crucial for understanding the relationship between tokens, scales quadratically with the context length. This makes it impractical to use very large context lengths due to the high computational costs and potential for slower response times. Practical implications. In practical terms, when a conversation exceeds the context, the wait, when a conversation exceeds the the context length limit, the model essentially starts anew, unable to refer back to earlier parts of the conversation. This limits the applicability of LLMs in scenarios where maintaining long term context is crucial, such as complex dialogues or tasks that require recalling information from earlier in the conversation. To mitigate these issues, developers often use strategies like context length optimization, which is experimenting. Wait, what are the others? Hierarchical or multi-resolution models and LLM enhancing tools. Okay, so context length optimization, experimenting with different context lengths to find the optimal balance between performance and accuracy. Hierarchical or multi-resolution models, using models that can process input texts at multiple resolutions to handle longer inputs more efficiently. And then LLM enhancing tools is utilizing tools that help retrieve past conversation context without needing additional prompting. Yeah, I'm trying to think of ways that we can kind of inject subtle hints of the context into the current context. But that would require the model to understand the context and maintain the context. We would probably need another model to recognize the context and every now and then inject the context somehow into this model's input. However, these solutions are still evolving, and the inherent limitations of context length in LLMs remain a, si- a significant challenge in achieving coherent and contextually aware long-term conversations. Okay, all right. Okay, cool. So, um, you know what? Here's what we're gonna do. Okay, my God, dude. I don't know if that was coming through on stream. But okay, hold on. Give me a second. All right. So, here's what we're going to do. Okay? I hope this person doesn't have any settings that prevent small raids because I'm doing a pretty small raid. We are going to somebody called Mushy Mushi. Um yeah, that's going to be it for today's stream. I'm going to be raiding this person. Um, yeah, I'll try to stream again tomorrow. I want to do this thing, dude. I want to make it a thing. Uh, I'll try to stream daily. I mean, I keep saying this. I don't know to what extent I'm gonna do it, but yeah, I want to make this a thing where even if I'm not able to do talking streams, I'll do mute streams. I also want to get this whole RTMP thing set up, so I'm gonna be doing a ton of research on that now after stream. Um, so that I can set up the streaming thing for streaming from Linux to Windows and Windows to Twitch. But yeah, we're gonna carry. Also, before tomorrow's stream, I'm gonna try and finish off this example thing. The notebook thing for converting or for applying chat templates to the model and to the tokenizer. And maybe I can also look into the fine tuning thing as well. Or maybe I can do that on stream. I don't know. I'll see. Okay. Anyways, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.